Hello everyone, I'm Haja Herdi and today I'm going to present you the work titled Performance Analysis and Energy Consumption of H.264 and H.265 Video Coding Standards. This work is the result of joint efforts of me and Dr. INRT2022. Before starting, I would like to thank the Committee of the International Network of Research and Networking for giving us such opportunity. First of all, we are going to start with introduction and methodology. After that, we will discuss performance analysis, and then we will see the energy consumption results, and finally we will conclude with conclusion and references. Streaming of videos, be it music, movies, or simply just speech videos, has been growing rapidly in the recent past. Video codecs go along the way in determining the visual quality of a video. Therefore, it becomes important to compare the different video codecs in terms of their performance metrics and energy consumption. H.264 or MPEG-4 past 10, referred to as AVC, aims at resolving the problems raised by its precedents. The main advantages of H.264 compared to the previous codecs is efficient coding, resilience to errors, and its network friendliness. A new codec has been created named H.265 or also referred to as HEVC, High Efficiency Video Coding, to counterbalance the limits of H.264. In order to achieve this study, we encoded the original video into H.264 and H.265 using Python and FFmpeg. The resulting video from each of the codec will then be compared to the original video by calculating four metrics. Finally, we use Intel Power Gadget to calculate the average of power consumption of the processor. Now we are going to present the results of the performance analysis. From this figure, it is observed that PSNR values of H.265 are mostly higher than those of H.264, signifying the possibility of H.265 being a better video codec in terms of human perception. This means that a human observer is likely to conclude that H.265 has the best quality. On the MSE also shows that H.265 codec has the lowest MSE on PSNR comparison. Calculating just the PSNR average value is not enough. As already stated, PSNR measures human perception of the video codec. Human perception is in three color modes, Y, U, and V, representing luminance, brightness, blue color projection, and red color projection, respectively. From the analysis, it's evident that H.264 outperforms H.265 in luminance and blue color projection. However, H.265 outperforms H.264 in red color projection. For the second metric, the aggregate SSIM value for H.264 seems slightly greater than that of H.264. However, the average values are the same, 0.93 for both of them, and are almost equal to the optimum value of 1, indicating both of the two codecs perform particularly well in terms of SSIM. However, in this second figure, H.264 results are slightly better in terms of the blue color projection. For the third metric, VIF, which is a type of quality metric performance measure which takes into account that the quality of a video is directly proportional to the loss of information fidelity. In this plot, we can see that H.264 is slightly higher than that of H.265, indicating that it is the best in terms of VIF. This is confirmed by the average VIF score of 0.77 for H.265 and 0.79 for H.264. Finally, for the VMAF metric, which infuses human vision modeling together with machine learning, shows that H.264 performs better than H.265 when analyzed on the VMAF score. In order to use these video codecs in a sustainable way with the current high demand, we need to find which codec presents less energy consumption. For this purpose, we used Intel Power Gadget to calculate the average of consumption of power of the processor. The log results show a higher consumption of energy with the H.264 codec compared to H.265. Thus, the latest is a more energy-saving codec. To put it in a nutshell, we have analyzed the performance of the quality of the two codecs, focusing on four metrics. In the first metric, PSNR, we have noticed that H.265 is better than H.264 in encoding this particular video. In the second metric, SSIM, the performance is identical for the two codecs. For the third metric, VIF, H.264 slightly outperforms H.265. However, for the last metric, VMAF H.264 achieves better results. Nonetheless, it's worth noting that the high performance of H.264 in terms of the size of the video after compression with a reduction of 62% compared to H.264 with only 30.42%. Thank you again for this opportunity and thank you for your attention.